Hi everyone, I'm Nishchal. Today I'm going to explain one of my project on MCP agents. I have named it as Cyber Evidence Annotator. Every day, SOC analyst spends hours uh, manually taking screenshots of malware, opening it in some tools, drawing red boxes, sending email alerts. It's a boring and repetitive and wastes time. So I asked myself, what if an AI could do this physical work for me? So for that, the solution which I built is Cyber Evidence Annotator using Model Context Protocol. So MCP is a new standard that lets AI model connect to the tools. I built an MCP server in a Python that controls my Windows desktop and a web client that sends my natural language commands to AI. So, the- so let's go ahead and start with the demo of it. So here is the technical architecture in my GitHub page. I started running my Python file talk to mcp.py. So this is how the my local server looked like. So Cyber Evidence Annotator. So here you could see four buttons: launch evidence locker, stamp confidential, draw threat borders, close locker. And also if you enter the API key here, which is masked, so then you could enter a custom command over here to perform it, and it performs those entered command. So let's start with without API key, how we are going to work on launching an evidence locker. So for here usually first I need to open any evidence locker. Means normally I would have to find a file and open the paint ms paint manually. So here if I just click on it, mm, uh, the MCP, here you could see launch evidence locker. So it will automatically launch the Microsoft Paint. So MS Paint opens automatically. It loads the specific image. So uh, I have stored an image called as evidence.png, which simulates a suspicious network log. Uh, the agent didn't just generate a text, it actually reached into my operating system, found the specific evidence file, and launched the correct application, that is mspaint.exe. So here this is my evidence file. If you here you could see evidence file number, IP range, and core is target, core is database it is targeting. So next step is we are done with launching the application tool. Then is the stamp confidential. So what it does is it analyzes and marking the evidence. If so, I need to classify this evidence as top secret, so no one leaks it. So I click on stamp confidential. The AI receives this and the intent converts it into a tool and executes it on a paint window. So in my UI log, you could see here it executed the command mark evidence as confidential and called stamp classification. So uh, you see the logs here. The AI decided to call stamp classification tool with argument confidential. So then is the threat isolation. For threat isolation, you need to draw a border tool. So now I'll click ahead and go and click on draw threat border. So the agent here, what it does, the agent takes the control of the paint window and manipulates it to draw to the evidence. So here you could see it will flash. At that time, it flashed, maximize and restored. So in this specific demo, we simulate the drawing action by programmatically manipulating the window state, maximizing it to prove that agent has full control over the application window. So you could see the logs over here. It executed the command draw thread border called a draw thread border. So it also logged it. So now if I want any Gmail integration, so I want to send this okay thread to my about this evidence to my CISO. Then I'll enter a command like send email to CISO about this malware. So if I enter this and click on execute here, I need to alert the chief information officer, usually like sending it. I do not want to switch apps to Gmail. So I just tell the agent, send email to CISO about this malware. So you could see here, agent is execute the command, send email to CISO about this malware called. So here it already sent. Result is success email sent to CISO at cybercop.com via Gmail API. So this is how this works. So since it's a demo environment, I have hard coded the recipient in the tool definition for safety. But in the production, the AI would extract the email address dynamically from your prompt. This tool is designed to simulate sending an email in a real world deployment. You would just add your Gmail API credentials to MCP server .py file. So now let's see with API key how it works. So let me enter an API key. So far we used simulation for speed. Now let's turn the real brain. So I'm entering my Google Gemini API key here. So the key is masked, the input is masked, so it is safe. So now I'll enter the command over here. So I want to send one complex request like let me close this MS Paint, and now I'll open Locker, open the Locker and mark it confidential, please. I'll try to execute it. Now I gave the complex instruction. So the LLM analyzes this request and decide to call multiple tools in sequence. The current demo might only execute the first identified tool, but explaining the concept is the key. So this opened my Paint and it opened the evidence file. So here, and you could see like evidence locker MS Paint opened with case number and the task got completed. So this is one of the simple demo using Paint, but the potential is massive. Using MCP architecture, we could build agents that could isolate infected laptops on the network, reset the passwords in Active Directory, parses threat intel feeds automatically. This is a future of autonomous security operations. Thank you for watching.